Guys, this is Bongani from The Edge. As I said from the beginning, we're going to be having like a complete expression, but in order to do that, I said let's focus on each and every function that is inside, right? So we're going to have this one, let's call this one A, and I have this one, let me call this one B, C, and D. So we're going to solve A, B, C, D individually, then after that we're going to combine all of them, then we're going to solve the whole thing, because I think it's simpler if you look at it with that perspective. Alright, so let's start with A. So we're going to have cos 130 degrees. So if you think about cos 130, let me draw my Cartesian plane that is useful on the side. As we know, A, so we have cast, right? So we know this is the third, second, first, it's the fourth quadrant. We all know this one is 90 degrees plus x, or 180 degrees minus x. And on this one, we know it's 90 degrees minus x. And we know on the third quadrant, we're going to have 180 degrees plus x. And on the fourth quadrant, we're going to have 360 degrees minus x. So we know that all of them here are positive, only sine is positive, tan is positive on the third, 4 on the fourth, cos is positive. Alright, so now what we are going to do is we're going to focus on how to actually change this angle into something that looks like 180 minus or 90 plus or 180 plus or something like that. But since we can see that 130 is here in this particular quadrant, so let's try to represent 130 in terms of 180 minus x. So we can say cos 180 degrees minus, what is 130 in terms of 180 in a certain angle? It's 180 minus 50 degrees. Then we can say that this comes out to be cos 50 degrees if you think about it, right? Or even if you looked at it from a perspective of 90 plus 40 degrees. Yes, 90 plus 40 degrees. And now if we pay attention to the second function, which is sine 90 degrees minus theta. So sine 90 minus theta, we all know that will generally change into cos theta. So this will be cos theta, and on C we're going to have sine 400 degrees. Then how can we express 400 degrees? 400 degrees can be 360 degrees plus 40 degrees. So 400 can be 360 plus 40, that's 400. And if you think about it, if we go around like this and go back to this point, we're going to say we've went around 360 degrees. So it means that on our angle, on our side, we added 40 degrees. Right? If now we've added 40 degrees on this 360, we're back on the first quadrant. So meaning that this expression of 360 plus an angle, it's in the first quadrant. And on the first quadrant, what is sine? Everything is positive there. So we can change it into sine 40 degrees. Then D, we're going to have cos minus theta. As I said, minus theta we're going to consider as if like it's an angle that is in the fourth quadrant. And we know only cos is positive there, so it's going to be cos theta, right? So now since we have all this data, therefore we can convert this whole expression that we have there at the top to be something like cos 50 degrees minus cos theta, so about that, minus cos theta, then divided by sine 40 degrees and plus cos theta. Okay, let me remove this just for some space. Alright, so now this is where you have to start to think hard. And what do I mean by that? If you pay close attention to these two expressions, the one that is on the numerator and the one on the denominator, they kind of look similar. There's only just a glimpse of difference between them, right? And what is it? The difference is these values that are here. And how can you make them look the same. It's up to you what you can do. You can choose to change the sine 40 degrees to look like cos 50, or you choose to make cos 50 degrees to look like sine 40 degrees. What do I mean by that? Since we know that from the reduction formulas, so the reduction formulas, you see that they are very useful for us. If you remember correctly, if we have something like this, which is something that we had, right, we can actually write that down as cos theta, right? So if I can apply this principle on the value on the denominator, I think we're going to be on the right direction. So if now I want to represent sine 40 degrees in this manner, we can basically say sine 90 degrees minus 50 degrees, like that. 90 minus 50 is 40. Then what does this change to be? Goes to cos 50 degrees, which is this principle that we just applied here. Nothing new, something that you know, and you are expected to know this. Now what we can do, we can go back to our expression there at the top and perform the following. We can actually go back and say cos 50 degrees minus cos theta, and we're going to have cos 50 degrees plus cos theta. Yeah, so guys, this is our answer. Thank you guys. I hope you enjoyed this video and hope it made sense. If you have any question, make sure you leave it on your comment and I'll get back to it.